What is PC power management? There's a common misconception about PC power management being the act of powering down PCs. This is far from reality. It's really easy to do when you manage your own PC because you just have to press a button, but it gets a little trickier when you enter big networks. The main reason for PC power management not to be massively deployed is because people doesn't want to lose time. So the final user is afraid of losing time with the PC powered off. The IT manager wants to have the PC network responsive enough to do patch management and updates in the network. And as I explained, the final user is really finicky about having to wait for the PC to do some maintenance stuff. So the best way to solve this kind of problem is to put some automation in place. That's why you don't see a manual faucet in an airport, for example, because to shut down your own PC is not PC power management, nor it is to shut off a whole network at the night. The main concept you have to learn in this case is the concept of PC power states. A given PC can be in three basic power states. It can be off, it can be standby, and it can be on. This is obvious. But the real important concept is to learn that there's a huge difference in energy consumption between the on state, is roughly 100 watts with the modern PC including the monitor, 5 when in standby and 2 when off. So with the same energy that 100 watts light bulb consumes, you can power a whole PC, or you can also power with the same amount of energy 20 sleeping PCs. We can also have faulty states, PCs that stay awake or on when they shouldn't, or PCs that are off when we don't want them to be off. In a given network there can be lots of PCs that aren't powered down correctly in the night, and then we have PCs that are off when we are expecting them to be updating and doing important things in the network. So how can we fix this considering the needs of the user, the company, and the savings? The way to do it is just to make the PC follow the desired power states regarding the behavior of the final user and the IT administrator. For example, when the user goes to lunch, the PC should enter a low power state, and also when some important update arrives in the morning, the PC should wake up and receive it gratefully. We also have to adapt the PC power states to the normal day of the user. They get coffee, they go for lunch, they have some meetings, then at the final of the day they go home. They also can be out of the office for several weeks. So a managed PC will be permanently adapting to the correct energy state. It will be in low power state during the night, it will be active in on state during the day and adapting to the ins and outs of the user, and then in the night it will be again in a low power state. The unmanaged PC, in contrast, will be wasting energy during the night. It will remain on without adapting to the user's behavior during the day, and then it will remain on in the night, and it can be in that state for days, weeks, months, or years, spending way more energy than needed. This misbehavior creates cases where PCs are on like 18 hours a day, like in a bank, and they're not used more than 8 or 10 hours a day, or in hospitals where a doctor uses a PC no more than 4 or 5 hours and it can be on the full day. Financially, this means that a managed PC can cost in energy about 35 euros a year, while an unmanaged one will spend like 110 euros per year. If you multiply these figures by the number of PCs you have in your network, you can realize the importance of this problem. So what do we need to cure this? We need something that's easy to set up, that is really simple to maintain, something that's friendly with the user and IT people, and something that's permanent, that you can set up and forget. This is the kind of solution that Surveyor from Verdian can give us, and in the next video we can learn a little more about it.